Hello everyone, welcome to Performance Testing Mentor. In today's video, we are going to look at a very common and very important performance testing interview question. Imagine that you are working on a performance testing project and you are running a load runner test. Initially, everything looks good. Your transaction response time is around 2 seconds. But as you increase the load suddenly, the response time starts increasing and eventually it reaches around 8 seconds. Now imagine that interviewer gives you one more condition. There is no Dynatrace, no AppDynamics, and no other application performance monitoring tool available. And the interviewer asks you, how would you identify the bottleneck? What would you do? Would you immediately check CPU? What if CPU is normal? Would you check memory? What if memory is also normal? And most importantly, how would you prove which layer is actually responsible for the performance degradation? In this video, I'm going to show you the exact thought process I would follow as a performance tester. And we are not going to run an actual load test in this video. Instead, we are going to use realistic performance scenarios and illustrative graphs to understand how we could investigate a bottleneck when an APM tool isn't available. Before we go any further, I want to address one of the most common mistakes I see when people answering performance testing interview questions. Let's say we collect the server metrics and we see CPU at 95%, memory at 82%, and disk utilization at 70%. Now, if I ask you which one is the bottleneck, can you immediately say CPU? Actually, no. We do not know it. And this is very important point. We should not simply look at the highest metric and call it as a bottleneck. A high CPU utilization is an observation. It tells us that CPU is high. But it does not automatically tells us that CPU is the reason users are experiencing high response time. As performance testers, our job is not to just collect the metrics. Our job is to use those metrics to explain the performance problem. So how we should approach this situation? I want you to remember 5 simple steps. Observe, correlate, form a hypothesis, verify, and finally conclude. Let's say I observed that CPU has reached 95%. I don't immediately say CPU is the bottleneck. Instead, I form a hypothesis. My hypothesis could be CPU saturation may be contributing to the response time degradation. Now, I need to find supporting evidence. Does the response time increase at the same point? Does throughput scaling? Are requests waiting for CPU? Are there related application metrics showing resource saturation? Are errors or timeouts increasing? If the evidence supports my hypothesis, then I can move forward confirming CPU as the bottleneck. If it doesn't, I reject that hypothesis and continue my investigation. So the mindset is very simple. Do not just find an abnormal metric. Find evidence that explains the performance problem. Now let's talk about the first practical step. Before looking at metrics, understand the application architecture. For example, let's assume our request starts from LoadRunner. It is generated by the load generator. The request then goes through a load balancer. From there, it reaches the web server. The web server communicates with the app server, and eventually, the application server communicates with the database. Now, this is just an example architecture. In a real project, your architecture could be completely different. You could have multiple web servers, multiple application servers, API gateways, caching layers, microservices, messaging systems, and so on. So before I start monitoring anything, I want to answer one simple question. Which infrastructure layer does my transaction actually touch? Once I know the transaction path, I know which components I need to investigate. Now let's come back to the main question. If there is no APM tool available, what can we actually monitor? The answer is quite a lot. At load generator layer, we can monitor CPU, memory, network, disk, and process. At the load balancer layer, depending on the technology we are using, we may monitor connections, throughput, queues, and resource utilization. At the web server layer, we can look at the CPU, memory, network connections, and request statistics. At the application layer, we may need to monitor CPU, memory, threads, JVM related metrics, garbage collection, and connection pools. And at the database layer, we may investigate CPU, memory, disk IO, connections, weights, and logs. In addition to these metrics, logs can provide very useful supporting information. So remember this, no APM doesn't mean no monitoring. It simply means that we have to collect and correlate the information ourselves. So where exactly does all the evidence come from? We normally combine information from several resources. First, we have our LoadRunner results. LoadRunner tells us what is happening from the virtual user's perspective. We can look at response time, throughput, transaction rate, errors, and other performance results. Then we have the operating system metrics. These tell us what is happening at the infrastructure level. We may also have application server or database native metrics that provide more detailed information about individual components. And finally, we have logs. Logs can help us understand errors, exceptions, timeouts, and other events happening during the test. The important thing here is we don't look at these sources independently. We correlate them based on the time and load. That correlation is what helps us move from simply seeing a problem to understanding the problem. Now let's start the actual investigation process. So the first thing that I want to establish is a baseline. Before starting the performance test, I want to understand the normal condition of the environment. For example, the application server CPU is already at 70% before the test begins. If the CPU reaches 85% during the test, that's one situation. But if the server CPU started at 10% and reached 85% during the test, that's a very different situation. So the baseline gives us a reference point. It also helps us identify whether a problem existed before the performance test even started. And this is something I would definitely mention in an interview. I don't just monitor during the test. I establish a baseline before the test. Now, let's take a realistic performance troubleshooting scenario. Again, the numbers you are seeing here are illustrative performance data. We are not executing a live LoadRunner test as a part of this video. Let's assume that we start our test with around 500 users. At this point, the response time is relatively stable. As we increase the number of users, response time increases gradually. But after we cross a certain load level, something interesting happens. Response time start increasing sharply. Now look at the application server CPU. We see that CPU is also increasing significantly around the same period. So now we have two important observations. First, the user facing performance is getting worse. Second, an infrastructure resource is becoming heavily utilized around the same time. Is that enough to declare the application server as the bottleneck? Not yet. We need more evidence. So let's add one more important metric, throughput. At 500 users, let's say we are getting around 200 transactions per second. When we increase to 1000 users, throughput increases to around 380 transactions per second. So far, the system is scaling reasonably well. But now we increase the load to 1500 users. What happens? Throughput only increases slightly from around 380 to 400 transactions per second. But response times jumps approximately 2.3 seconds to 5.8 seconds. And application CPU reaches around 96%. Now we have a much stronger signal. We are adding more users, response time is increasing significantly, CPU is approaching saturation, but throughput is no longer increasing proportionally. This is a classic pattern that tells us we may have reached a resource limitation. At this point, application server CPU becomes a strong bottleneck hypothesis. Now comes the part where many candidates make a mistake in an interview. The interviewer may ask, so is the application server the bottleneck? And the candidate may say, yes, CPU is 96%, so the application server is the bottleneck. I would not give that answer right. Why? Because we have a strong hypothesis, but we haven't verified it. High CPU tells us that CPU utilization is high. It doesn't by itself prove that CPU is responsible for the response time degradation. We need supporting evidence. And that's what makes performance troubleshooting different from simply looking at monitoring dashboards. So let's say CPU is our current suspect. The next step is correlation. I correlated CPU behavior with LoadRunner response time and throughput. Then I look at the related metrics. For example, are application threads becoming saturated? Are connection pools getting exhausted? Are requests waiting? Are errors or timeouts increasing? Do the application logs show any relevant exceptions? And most importantly, does this behavior consistently appear when we reach the same level of load? If multiple pieces of evidence point towards the CPU saturation, then I have a strong basis for concluding that CPU is the likely bottleneck. But if the CPU is high while the application isn't showing any corresponding saturation and any resource is clearly constrained, then I should not blame CPU. I reject that hypothesis and continue the investigation. This is why I likely use the phrase suspect, correlate, verify, and prove. Now let's answer another question that may come up in the interview. If you don't have an APM tool, what tools do you actually use? For Windows servers, we can use tools such as Performance Monitor, Resource Monitor, PowerShell, and Event Viewer. For Linux servers, we have tools such as Top, VMstat, IOStat, SAR, Free, and SS. At the application server and database layers, we can use the monitoring capabilities provided by those technologies themselves. And of course, we can use application and system logs. I'm intentionally not going into the individual commands and metrics in detail here because that's where the next part of this series become much more interesting. We are going to take each infrastructure layer separately and understand exactly what to monitor, what the metrics means, and how to determine whether that layer is actually becoming a bottleneck or not. Let's quickly bring everything together. If I asked how I monitor and troubleshoot an application without any APM tool, my process would be first, I understand the application architecture. Then I identify the infrastructure layers involved in my transaction. I identify the relevant metrics for each layer and I establish a baseline. During the performance test, I monitor how these metrics behave as the load increases. Then I correlate the infrastructure metrics with LoadRunner response time, throughput, and errors. If I see any abnormal behavior, I form a bottleneck hypothesis. I then verify that hypothesis using supporting metrics and logs. And only after the evidence supports my conclusion, I identify the likely bottleneck. So, the key takeaway from today's video is don't just collect metrics, explain the performance problem. Now, let's come back to the original interview question. The interviewer asks, how do you identify performance bottlenecks when an APM tool isn't available? Here is how I would answer it. If an APM tool isn't available, I use LoadRunner metric along with OS level monitoring and logs. I first understand the architecture and establish a baseline. During the test, I correlate response time, throughput, and errors with the infrastructure metrics. If I identify an abnormal metric, I treat it as a bottleneck hypothesis rather than immediately calling it as the root cause. I verify the hypothesis using supporting metrics before confirming the bottleneck. Notice the difference. I'm not saying I monitor CPU, memory, and disk. Instead, I'm explaining by investigation methodology that demonstrates to the interviewer that I would not only understand the application monitoring but also the bottleneck analysis. Now let's take it one step further. Imagine that during your next performance test, you notice something interesting. Your load generator CPU reaches 95%. The interviewer asks, is the load generator the bottleneck? What would you check? Would CPU alone be enough? What other metrics would you monitor? Which operating system tools would you use? How do you correlate those metrics with LoadRunner? And most importantly, how do you prove to the interviewer that load generator is actually limiting your performance test? That's exactly we are going to cover in the next video. We'll take the load generator layer, go metric by metric, look at the relevant graphs, and then work through an interview style bottleneck scenario. If you are preparing for performance testing interviews, make sure you follow this series because we are going to approach each layer from the perspective of how an experienced performance tester actually investigates a bottleneck. Thanks for watching Performance Testing Mentor. I'll see you in the next video.